All right, and thanks again, everyone, for being here. I'll talk about some of the challenges of working with 30 years of heavy data and some of the results that we get in comparison with the ERA5 data that we know and love. And so I went ahead and posted a YouTube video on how to gather the CARRA data from the Climate Data Store. And we already heard this morning a really nice presentation on the same topic. Um, and let's see. The other point on gathering data is that, yes, indeed, 31 years of 2.5 kilometer data, it takes time. The good news is that the Climate Data Store is retrieving the data a lot faster than they were a year or two ago. And so don't believe all the rumors that it takes too long to gather these data. And yeah, you have to be patient. It's heavy data. And I was happy to hear earlier a question asking for a regional subsetting of the data. That will be even more relevant for CARRA 2, which I think not all the users will want the full Arctic domain or a lot of the Northern Hemisphere at that resolution. So it seems a strong need for regional subsetting. I'll talk about resampling ERA5 to CARRA data to make a difference map. And I've already posted data here. I should push it again actually to I think I'll just do that now for fun here. I just have to go like this so that if anyone's grabbing the data now, there it is. It's pushing the latest version up to GitHub. Okay, great. That seemed to work. And then I go back for my presentation. So there's a lot in this code about not only resampling ERA5 to CARRA, but handling the data. There's also in the same repository the gather data script that I talk about in this video. And I intend to make a video describing this process. It's just a few codes, but the codes get kind of long. And we heard an earlier presentation today. We did fewer lines of code. But I think this is still quite useful to get you into working with the CARRA data. So I'll compare some ERA5 versus CARRA for both 2-meter temperature and total precipitation. And this is for this west domain of CARRA. So already here you see ERA5 June, July, August for a 31-year period that is resampled to the CARRA grid. I use nearest neighbor so you can see the kind of Lego effect if you squint your eyes here. And we can see this circle is at the minimum. So the minimum temperature for ERA5 is -14 Celsius at this latitude, longitude, and the maximum is down here. Here's the same thing for the CARRA data. Overall minimum in summer -16. The zero, the max is down here. I'll just flip back and forth between these and look at like North Greenland. I think that's the most obvious difference between these data sets, where ERA5 is colder in North Greenland in summertime. But to really get it to appreciate the difference, here's the difference map made using the code at that repository. And I just make some notes that, well, these data sets are in general agreement over the North Atlantic. And in summer, the southern Greenland ice sheet, ERA5 and CARRA are in agreement. And along the Greenland ice sheet margin, see the white colors, that's where difference is 0. So there's a strong boundary effect between land and ice sheet, but it seems to be to our benefit if you're using ERA5 to get an accurate number right at the ice margin. However, warm differences over northern Greenland, Iceland, Svalbard, and this part of the Arctic Ocean, etc. It's difficult to see, but you can actually make out the Northeast Greenland ice stream, and that's a testament to the very fine resolution of the terrain data used in CARRA. And yeah, you'll see some strong differences in fjords, where of course at 31 kilometers, ERA5 cannot resolve these large amplitude terrain variations. Here's at the annual scale, and there's widespread warm difference for ERA5. So ERA5 is warmer over the entire ice sheet at the annual scale. There's a warm spot over Kane Basin, Nair Strait that David Bromwich was talking about. It's a very, very interesting region biologically, culturally. Lots of studies focus here in atmospheric dynamics. So that's an interesting difference. But again, ERA5 warmer over Iceland, Svalbard, and say Baffin Bay. The winter months, it's just a stronger average difference, above 4 Celsius for most of the Greenland ice sheet, and then a cold difference. ERA5 is colder than CARRA over land. I'll talk about, I have in situ data to compare these to get an idea of the absolute accuracy of both ERA5 and CARRA. But then these are the averages, right? Here's a cruder map of the trend in ERA5. So ERA5 has a warming trend over Baffin Bay, warming trend over Svalbard. At the annual scale, a cooling trend, a very weak one over central Greenland, no trend here, and a cooling trend over the North Atlantic. CARRA has really only a warming trend, or not any trend here in the southern North Atlantic. So go back to ERA5, a cooling trend, if I did the trend calculation correctly, and kind of no trend here for CARRA. The strongest trend around Svalbard and Kane Basin, not Kane Basin, the CARRA Sea, Laptev Sea, sorry, CARRA Sea, Barents Sea, that's it. The difference in the trend, the blue colors suggest that the CARRA trend is more positive everywhere. And so a stronger warming trend in CARRA over around Svalbard and the Barents Sea is a consistent result with Isaksen and others recently, where here's the CARRA trend, it's stronger than the ERA5 trend. Now to the in situ data, I'll emphasize the longest records we have from Summit and Swisscamp as part of our network that have now merged. The PROMICE network down low, the red sites merged with the blue sites, the Greenland Climate Network, carried forward by the Geological Survey of Denmark, Greenland, where I work now. I've compiled the Swisscamp data. We have 33 years of continuous measurements. You see summertime warming of 1.3 Celsius, an annual warming of 2.4 Celsius. That's by combining these in situ records. Similarly, at Summit, it was the University of Wisconsin that kicked off the Summit temperature measurements in May of 1987. And through 1994, there was some overlap. There should be some overlap here, 96, 97. And here we have 36, actually now 37 years of temperature data and other climate data from Summit. So how do these compare with CARRA and ERA5? Swisscamp at the annual scale, in situ is the black curve. It is very encouraging to see the strong variability is captured in all of these data sets. And the truth is that CARRA is assimilating the in situ data, not all of it, but most of it. And here you see that warm difference that we saw for ERA5 versus CARRA. And down here, some statistics. So CARRA has an average bias, which is just above 1 sigma. And the bias at ERA5 is well above 1 sigma, and a slightly higher correlation for CARRA at the annual scale at SwissCamp. Winter, and this is where the temperature differences are largest. They dominate the annual signal. ERA5, quite a bit warmer. The difference is 5 Celsius for this location in winter. I start to wonder if some of this is a terrain smoothing effect. The near margin terrain should be smoothed lower at 31 kilometers. So some of this warm bias is probably due to that, but that would not explain what we see at summit, where there's little terrain bias. But here we have a nice agreement with the CARRA data. High correlation, it's about as high as for ERA5. And let's look at summer. So in summer, CARRA is slightly less or slightly larger bias than ERA5. And you saw in the earlier maps that the southern ice sheet has a small difference with ERA5 and CARRA. And here it seems that ERA5 is doing very well for summer at this part of the ice sheet. Here's now summit at the annual scale. The warm difference for ERA5, the in situ data are closer for CARRA, and some of the deviation, so they're very close in some years and not so close in others. This may be due to not all of the GCNet data was being assimilated by CARRA. That's something that we need to check. Winter, CARRA, ERA5 is warmer again than in situ and CARRA, so it's looking really quite good for CARRA, but not always. For example, the trend magnitude here, I haven't quite figured this out. It may be that the in situ data, for one, has a warm bias because these are not actively ventilated temperature measurements. That could explain the temperature difference, the inconsistent result. And then a shallower observed trend than in ERA5 or CARRA. These are really quite different results for this central part of Greenland. We should try to understand this better. And again, I suspect some of the error here is actually in the observations. This is a summary table, and so you saw SwissCamp, you saw Summit, 29, 33 years of data. There are other stations like NASA U here, 12 years of data, or 20 years from Tunu North, and those are on the map. Most of these locations are high on the ice sheet. SwissCamp was the lowest, but I haven't yet compared with the much lower elevation prom ice sites, and there we'll start to run into terrain bias issues. But in summary, when the box is green, it's a more favorable correlation in general for CARRA, and the bias is lower at the annual scale for CARRA. So the check mark is it's doing better. And at the summer scale, it's actually ERA5 has a lower bias for this collection of sites. Correlation still higher for CARRA, and the root mean squared difference is lower for CARRA in summer. In winter, CARRA is performing better again, with lower bias on average, higher correlation, and lower RMS difference. With the short remaining time, I'll shift to precipitation. And here is the annual total precipitation for CARRA, 31-year average. Maximum here along Iceland, 11 meters water equivalent here in the CARRA data. And so above, or around 3 meters, above 3 meters here in Southeast Greenland coast. You have a very dry northeast ice sheet. Apparently I never knew this. Northern Baffin Bay seems to be quite a dry place at the annual scale. Here's ERA5. Maximum over Iceland 3.2 meters or 3.3 meters. Similar regional patterns and the difference. Where you get really strong local differences, and then that spillover effect where ERA5 is wetter inland, and agreement. Well, I've got some more detail in, I think, one more slide. Here you really see again, strong local scales when CARRA can zoom in to 2.5 kilometers. We see a lot of regional detail patterns, and it's delivering, it's concentrating in moisture closer to the coasts. Yeah, I've been comparing not just ERA5, but some other regional climate models with observations, approximating total precipitation using snow cores data. And the general picture is for all of the regional climate models, including CARRA, is they all have an inland dry difference and a coastward wet difference relative to these data. So this is a map that is attempting to calibrate CARRA to accumulation to account for also drift snow sublimation and other effects, to try to produce the most accurate snowfall accumulation map that we have for Greenland. So this is work in progress, and I think I'll leave it there, and thank you for your attention.